Hello, this is video number 73. In this video, we're going to do part 1 of rational exponents. Here we go. So remember, rationals are fractions, and so they can be exponents too. So our job here is to rewrite these following as radicals, square roots or cube roots. So remember, the half power is equal to the square root of a number. So 10 to the 1/2, we could rewrite as square root of 10. Okay. P to the 1/3, we could rewrite as the cube root of P. M to the 1/5, that's the fifth root. So if it has a 1 in the numerator and just another number in the denominator, then it's just a root, like the fifth root of M. Here, this has both, a number in the numerator other than 1 and a number in the denominator. Remember, the top one is the power, and the bottom one is the root. We can see this by breaking it up. This is x to the 7th, all to the 1/3. That works because when it's a power to a power, you multiply exponents. 7 times 1/3 is 7/3. So these two things are equivalent. But now we can see that this is the cube root of x to the 7th. Like that. All right, this one we can rewrite, if we want, as b cubed to the 1/4 power. Okay, so this would be the fourth root of b cubed. This one, once we got it, we can realize that 9 is the power, so this is w to the 9th. 2 is the root, so that's just square root, w to the 9th. Okay, so once you get used to that, that's not so bad at all. Sometimes you're given problems where they're either perfect cubes or perfect squares, and the expressions like these work out to whole numbers. So you can use your calculator actually to get the whole numbers, but we're supposed to use the laws of exponents to show how you get those numbers. Okay, so there's a question like this on the quiz, and you got to kind of show how to get what the calculator gives you. Well, we're going to break it up. So I'm going to break this up into kind of differently than before. I'm going to put the fraction on the inside when I'm doing a problem like this. 8 to the 1/3 squared. 8 to the 1/3 is the cube root of 8. And the cube root of 8 is 2. So this is 2 squared, which equals 4. Okay, on this one, same thing. 16 to the 1/4. Why do I put the fraction on the inside this time? It's because it's kind of easier to do that. Easier to take the root first and then raise it to the power. 16 to the 1/4 is the fourth root of 16. It's all cubed, which is 2. Cubed, which is 8. All right. 32 to the 3/5. So that would be 32 to the 1/5 cubed. 32 to the 1/5 is same as the fifth root of 32. You could use your calculator, but that's just 2. So this is 2 cubed, which is 8. So these are kind of special examples where they work out the whole numbers. And usually they ask you that because they want to know if you understand like the square roots and cube roots of whole numbers. So here, 16 to the 5/2. This would be equal to 16 to the 1/2 to the 5th, which is the same as square root of 16 to the 5th, which is 4 to the 5th. And I need a calculator for that one. That works out to be 1,024. Okay, here we go. 27 to the 4/3. That's 27 to the 1/3, which is the cube root, to the 4th. 27 to the 1/3 is just 3. So that's 3 to the 4th, and that's 81. Last one. So we're going to break this up as 9 to the 1/2 to the 5th. 9 to the 1/2 is the square root of 9, which is 3. So 3 to the 5th, which is 343. Okay, so in the first problem, so when I was just writing it as a square root, it was helpful to put the fraction on the outside. On these, when I'm simplifying these problems, it was helpful to put the fraction on the inside. So it kind of depends on the problem. Okay, as usual, the same laws of exponents apply. When we're multiplying powers, you add exponents. So here, the first thing we're going to do is multiply 2 times 4 times 4, which is 32. Then we're going to add the exponents. So this is going to be m. I'm going to add up these guys. 2 plus 3 halves plus negative 2. It's actually 3 halves. And we're finished. Here, there's only a number 3. And we got to add these two exponents because we're multiplying powers. So 1/2 plus 4/3 is 3/6 plus 8/6. You can use a calculator with the ABC key, but it ends up being 11/6. And we'll leave it like that. Okay, when it's a power to a power, you still multiply. So 3 halves times negative 2 is negative 3. So this is p to the negative 3, which is 1 over p cubed. So all of these, like I said, you can use your calculator to do. 1/2 raised to the 3 halves. When you multiply 1/2 times 3 halves, you get 3/4. So this is a to the 3/4. Then, if they ask you to, you could rewrite this as a radical, but they didn't ask us to, so we'll just leave it. We can leave it as a exponent. All right, and when you divide, you subtract exponents. So 2 divided by 4 is 1/2. Then 7/4 minus 4/3. So 7/4 minus 4/3. Let me see, that's 21/12 minus 16/12. That's 5/12. So this is 1/2 x to the 5/12. We got that by subtracting. All right, last one. 4 divided by 2 is 2. Then when we subtract the exponents, 2 minus 1/2 is 3 halves. Okay, so just to show you whether they're whole numbers, negative numbers, or fractions, same rules apply. Okay, we're at the last part here. Sometimes we have to go backwards. We have to rewrite these as rational exponents. And, well, we'll learn a shortcut in a second, but we could just start by writing whatever's on the inside to the right fractional power. Since the cube root, this would be to the 1/3. A power to power, you multiply. 2 times 1/3 is x to the 2/3. But if you remember, the top is the power, the bottom is the root. So here, let's see if we can skip ahead a little bit. 5 is the power, 4 is the root, so it's to the 5/4 power. On this one, 7 is the power, 3 is the root, so x to the 7/3. And the very last one, this is d to the 6 is the power, 11 is the root, so it's 6/11. Okay, that was a big chunk of what we need to know, and you just got to practice and get used to it. So here are a few problems of each type. So on number 2, use the laws of exponents like I did to simplify them. You should get whole numbers for a and b. Okay, use the laws for 3 and 4 is like the last side. I think you should be okay. Good luck.